Justin here. Me and my friend Jordan's favorite band of all time, the Mias, just dropped their new album yesterday, and I can't stop listening to it. It has the perfect song for everything. Slower songs for relaxing and cooking, and some faster songs for running or singing in the shower. It's got me thinking about the speed of music, which is measured in beats per minute, or BPM. The BPM of each of the songs in the new album is in your warm-up activity. If you haven't completed it yet, you could do it now. Looks like you're ready, so let's get into it. So, Jordan creates these really cool visual representations of the BPM of the songs in different albums and puts them on plaques to hang up. Jordan says these are called box plots. For the Mia's newest album, Jordan created this box plot, but hasn't put it on a plaque just yet. Let's take a closer look. What do you notice about box plots? Try to write down at least 3 characteristics. Pause the video to do so now. Our observations here might be different, and that's totally okay. Maybe you notice that this number line scaled by 2s below the box plot. Or maybe you notice that there's a box in the middle and that it's split into 2 sections. Or that there are lines coming out from either end of the box, each creating a section outside of the box. So, how many total sections are there in a box plot? 1, 2, 3, 4. A box plot has 4 sections. 4 sections. Huh, that sounds familiar. What does this remind you of? In our last lesson, we worked with quartiles, where we split our data into 4 sections. Do you think quartiles and box plots are connected somehow? In your warm-up activity, you've already found the minimum, Q1, median, Q3, and maximum, also called the 5-number summary. What do you notice about where these numbers appear in the box plot? Where did you see these numbers show up in the box plot? You might have noticed that each of these 5 numbers coincides with where each of the 4 sections starts and ends. The minimum of 76, Q1 of 85, Q2 or median of 97.5, Q3 of 111, and the maximum of 118. What does each of the sections of the box plot represent? Since the quartiles help break datasets into quarters, this means each section of the box plot represents each quarter, or 25% of the data. Since we have 12 total data points, that means 3 of them are represented by each section. This first section represents the first 25% of the data. This second section represents the second 25% of the data. This third section represents the third 25% of the data, and this fourth section represents the last 25% of the data. So, if each 25% section represents 3 numbers, why are some sections of the box plot longer than others? Yeah, their spreads are different. The third section, from 97.5 to 111, for example, has the largest spread out of all the sections. It has a spread of 13.5, while the fourth section, from 111 to 118, only has a spread of 7. That's why this third section is almost double as long as the fourth section, despite both representing 3 numbers. What about the IQR? How is the IQR represented in a box plot? Since the IQR is the middle 50% of the data, it would be represented by the length of this box. That makes total sense because the IQR is between Q1 and Q3. So, what does a box plot help us visualize? A box plot visually summarizes the spread of the dataset using its 5-number summary. Each section represents 25% of the dataset. Jordan's birthday is coming up, and I want to make a box plot as a surprise gift to celebrate our friendship. We talk a lot on the phone, and since Jordan likes box plot art so much, I thought, why not make a box plot summarizing the duration of our phone calls? Here's the data for 11 of our most recent phone calls. What should we do first? Yeah, we should order it from least to greatest. There we go. Now, what do we need to find? The box plot consists of the 5-number summary. Pause now to find or calculate those numbers. The minimum is 12 minutes and the maximum is 71 minutes. Crossing off the same amount of numbers from both ends gives us a median of 44. Excluding the median, 12 to 41 is the lower half and 50 to 71 is the upper half. The middle numbers of both halves will give us the quartiles, so Q1 is 27 and Q3 is 59. Great! We should be ready to create a box plot now. Remember how the 5-number summary shows up on a box plot? They mark the start and end of each of the 4 sections of the box plot, and in order to plot them the right distances from each other, we need to first create the number line below. Let's start by figuring out how long this number line needs to be. Where will the box plot start and end? It'll start at the minimum of 12 and end at the maximum of 71. We would need a number line with a scale large enough so that all of these numbers would fit in, but small enough that it'll be easy to read the box plot. What scale do you think we should use? Scaling by 3s or 4s should be fine, but for this box plot, I'm going to scale it by 3s so it's a little easier for us to read. Okay, now that we have the number line, how do we create the box plot? Since we have the 5-number summary already, and we know these numbers mark the start and end of the box plot's 4 sections, we should mark where these numbers are first. Go ahead and draw 5 vertical lines corresponding to the 5-number summary. And here are those vertical lines marking the start and end of each section of the data. Remember, a finished box plot uses a rectangle for the 2 middle quarters and a line coming out of the box for the first quarter and the last quarter. I like drawing the middle box first and then the outside sections, but if you want to draw it in a different order, go for it. I'll draw a box from Q1 to Q3. Then I'll draw a line from the minimum to Q1, or the beginning of the box. And finally, I'll draw a line from Q3, or the end of the box, to the maximum. And there we have it, our completed box plot. Hopefully, Jordan likes the birthday gift and how it helped us learn how box plots work and how to create them from datasets. Be sure to jump into the activities to practice some more. See you next time! Hey.